Today's video will go over how to derive the equation of an ellipse centered at the origin. To derive the equation of an ellipse centered at the origin, we begin with the foci. We denote the foci -c, 0 and c, 0. Remembering that an ellipse is the set of all points x, y, such that the sum of the distances from x, y to the foci is constant. Taking a look at the figure, we see our two foci denoted, we see our arbitrary point xy, and we see our distance 1 and distance 2 highlighted in green. If there is a point a, 0 as a vertex of the ellipse, the distance from the focus point -c, 0 to the vertex a, 0 is a minus -c, which gives us a plus c. Similarly, the distance from the focus point c, 0 to the point a, 0 is a minus c. The sum of these two distances is a plus c plus a minus c, which gives us 2a. xy is an arbitrary point on our ellipse. We can define the following. Distance 1 as the distance from the focus point -c0 to the arbitrary point xy. Distance 2 as the distance from the focus point c, 0 to the arbitrary point xy. And again, in our figure, we see the two distances denoted in green. We see our two foci, and we see our arbitrary point. By the definition of an ellipse, d1 plus d2 is constant for any point xy on the ellipse. It follows from our previous slide, where we talked about the distance of the focus points to the vertex to determine that that equaled 2a, that any other two arbitrary distances, d1 and d2, will also equal 2a. Previously, we stated d1 plus d2 equals 2a for any point on the ellipse. Recalling that the distance formula states d equals the square root of the second x minus the first y squared plus the second y minus the first y squared. Therefore, the distance from the focus point to the arbitrary point xy will be the square root of x minus -c squared plus y minus 0 squared. The distance from the second focus point to that arbitrary point is the square root of x minus c squared plus y minus 0 squared. We now have these two new distances equal to 2a. Remember, we said two distances was equal to 2a. We have these larger formulas now that we can substitute in. And we begin to derive the equation. Starting with our two new distances, d1 plus d2 equal to 2a, we get the square root of x plus c squared plus y squared plus the square root of x minus c squared plus y squared equals 2a. Now, if you're wondering what happened to the minus 0 for those y squared terms, y minus 0 squared is equivalent to y squared. We begin to do some algebraic manipulation. We start by subtracting this term, x minus c squared plus y squared square root. We move it from the left-hand side to the right-hand side of our equation, giving us square root x plus c squared plus y squared, now equal to 2a minus square root x minus c squared plus y squared. We want to clear the square root on the left-hand side. We do so by squaring both sides. This leaves us with x plus c squared plus y squared without the square root on the left, and the entire right-hand side squared. You'll notice that is noted in brackets. Now we use the FOIL technique to expand some of our terms. We start with x plus c squared. So we would write that x plus c times x and we would use FOIL, and that would give us x squared plus 2cx plus c squared. The y squared just drops down. And over here, when we use FOIL on this entire term, we get 4a squared minus 4a times the square root of x minus c squared plus y squared plus x squared minus 2cx plus c squared plus y squared. It's getting pretty ugly. We're going to clean it up here on this next slide. The terms that we were left with are bold at the top, and what we'll do is a little bit of algebraic manipulation here. We note that we have similar terms on both sides. So using subtraction, we can get some of those to cancel. We can subtract x squared, c squared, and y squared from our left-hand side. What we do to the left, we must do to the right. We have a minus x squared, minus c squared, and minus y squared on our right-hand side. Notice the cancellations. Similarly, on the right, x, c, and y disappear, leaving us with 2cx equal to 4a squared minus 4a times the square root of x minus c squared plus y squared minus 2cx. We'll shift a few of the terms from the right over to the left, again using addition and subtraction. So we'll take this 2cx, add it to both sides, and we're going to take 4a squared and subtract it from both sides. This gives us 2cx plus 2cx equaling 4cx, and minus 4a squared equal to negative 4a times the square root of x minus c squared plus y squared. The next step is to divide everything by 4. This gives us 4cx divided by 4cx. Negative 4a squared divided by 4 gives us negative a squared. And this entire term, negative 4a times this distance formula inside, divided by 4 gives us negative a times the square root of x minus c squared plus y squared. And now we're going to square both sides. So we're going to square cx minus a squared, and we're going to square negative a times this square root, so that simply gives us negative a squared, which equals a squared, because we have a negative a times a negative a, so a negative times a negative gives us a positive a squared. And we keep this distance formula term in brackets and just mark it as brought to the second power for now. Once again, in bold, we see what we just left off with. And now we use FOIL on the left-hand side, which gives us c squared times x squared minus 2a squared times cx plus a to the fourth power equal to our entire right-hand side term. We're not touching that just yet. In the next step, we will. So squaring this term right here leaves us with x squared minus 2cx plus c squared plus y squared. The a squared stays the same, and it still times this entire string of letters and numbers. And on this side, the left-hand side, we haven't touched anything yet. Now we work again on the right-hand side and multiply that a squared through all of our terms. We get a squared times x squared minus 2a squared cx plus a squared c squared plus a squared y squared. To move from this step that we're showing right here to the following step, the first thing we do is multiply everything through by a negative 1. This will change our signs, giving us a negative c squared x squared, a positive 2a squared cx, a negative a to the fourth, negative a squared x squared, positive 2a squared cx, negative a squared c squared, and negative a squared y squared. We then begin to manipulate some of the terms, starting with 2a squared cx. We can cancel that out by subtracting it from both sides. So minus 2a squared cx minus 2a squared cx, those terms disappear. We'll move the a to the fourth to the right-hand side by adding it, and we see that a to the fourth appear here. We will move a squared x squared from the right to the left by adding it, and that appears here. C squared x squared stays, and remember, since we multiplied by -1, it's minus c squared x squared. And the other thing we'll do is we'll move this minus a squared y squared to the left by adding it, and it appears here. And we're left with our minus a squared c squared, giving us this entire term, a squared x squared minus c squared x squared plus a squared y squared equal to a to the fourth minus a squared c squared. Again, in bold, it's listed at the top. And we get to factor some things out. Now, all that manipulation and moving around on that last step was done so that we can factor out an x squared on the left-hand side and an a squared on the right-hand side. We factor out the a squared, leaving us with a squared times a squared minus c squared on the right. Factoring out an x of just these two terms here, we have x squared times a squared minus c squared plus our a squared y squared. Here's the tricky part. We're going to make a variable substitution. We're going to let b squared, a new variable, we did not previously have any b's, we're going to let b squared equal a squared minus c squared. We notice we have an a squared minus c squared on both sides, the left and the right, and we just replace it with b squared, giving us x squared times this b squared plus a squared y squared, we haven't touched that term, and a squared b squared on the right. It looks a lot cleaner now. We start with what we left off with. We divide everything by a squared b squared, and you'll see why we're going to do this in the next step. Each term, you'll notice, is divided by a squared b squared. We have some cancellations that can be made. These b squareds go away, these a squareds go away, and these a squared b squared over a squared b squared is a special form of 1, and we end up writing it as 1. We are left with x squared over a squared plus y squared over b squared equal to 1. And that's it. This is our equation of an ellipse centered at the origin.